Well, define for us. I mean, I've always wondered, how do you technically, how is a gem different than a stone or a rock or a crystal? What are the parameters that define these things?
It's a really great place to start. Thank you for asking. So let's start with crystal. Um, so a crystal, depending on what area of expertise we're using to create this definition, is going to be considered to be a generally solid substance that has a regular composition. So it's homogeneous, the same stuff throughout, more or less, and has a regular and repeating symmetrical structure. So think of it as like a fractal or a tessellation, where the same unit just kind of repeats on itself. Now, given enough space, it will form regular angles. It'll be bound by geometric planes with symmetry, like this piece of smoky quartz from Brazil here. But sometimes we end up with things where that symmetry isn't always visible to the macro level. So here's some malachite, and it's got these little fibers of crystals that radiate out in the core. And if we could magnify them, we'd see the same kind of crystallinity to them, but it's on a micro level rather than a macro level. So, crystals don't have to be rocks or minerals. There are crystals in the body. There are crystals in our salt shaker. There's crystals all around us. Specifically, when a crystal is inorganic and naturally derived, so it's got that regular composition and structure, and then it's got that repeating symmetrical lattice formed by nature and inorganic. We call that a mineral. So examples of minerals could be quartz or calcite or diamond. And when one or more minerals aggregate or kind of like come together to produce a larger formation, we call that a rock. So some rocks are, things we expect to see, maybe a granite countertop or, a piece of chalk or slate. Other rocks are gem materials like lapis lazuli, which is a metamorphic rock that contains blue lazurite and white calcite and golden pyrite and as many as 20 other accessory minerals. And for any of the above, a rock, a mineral, a crystal, if we use it ornamentally, then we call it a gem. So the word gem has a little bit more wiggle room to it, which is why some people lean into it. Stone is another more nebulous term. I think if we wanted to be really technical, we would say that the word stone connotes any hard substance of geologic origin. So geologists themselves kind of shy away from the word stone unless it's part of the formal name of something, like hardstone or greenstone schist. Otherwise, it's too broad or vague of a term. In archaeology, we often use stone to denote something that has somehow been altered or shaped by human hands, like stone tools or standing stones. But truthfully, it's probably the broadest of all the terms. So a lot of people just kind of use that as their catch-all. And at the end of the day, the geology police are not going to show up because you used rock, mineral, crystal, and gem interchangeably. But if we understand what those things mean in their narrowest sense, it gives us clues as to what kind of substance we're describing and also what kind of energy they're going to have. Something like a mineral, which is a single crystalline substance, definitely produces a different kind of personality or presence than something like granite, which is a rock made of many different crystalline minerals. It's the difference between listening to a single voice and listening to a whole choir.
That's a great way to explain it. I liked that you pointed out that these are inorganic, that there are crystals that are organic and inorganic. What are some examples of organic crystals?
Sugar is one I'm sure we're all familiar with. We could also talk about substances that are going to be in the human body. So things like certain lipoproteins that are in our cell membranes, and hemoglobin, the pigment, the iron-based pigment that carries oxygen or waste to and from every cell. DNA has certain kind of crystalline qualities. We've got hydroxylapatite. It's a calcium phosphate mineral in our teeth and bones that gives some structure. And I mentioned at the start of this that crystals are usually solid, but there are also semi-crystals and liquid crystals. And the most important substance in our body that in a perfect state should be at least somewhat crystalline is water. So water has this ability to organize itself in any of the known crystal systems. The way those water molecules come together, they're polar. So there are regions that have a more positive or negative charge, even though the net charge of a water molecule is neutral, is zero. They kind of work like the north and south poles of a magnet to cause it to line up, and that's called hydrogen bonding. And the actual angles that they form are variable, which is very unusual for any substance not to have a regularity to it. It doesn't always abide by the same rules, which means water can organize itself in any of the crystal systems. Water can adapt its crystallinity to any sort of strong electromagnetic field. Even weak electromagnetic fields can cause them to organize into different patterns. And in a perfect world, every water molecule in our body should be in what's called a liquid crystal mesophase, this state in between liquidity and crystallinity. And that makes us living, breathing, walking crystalline beings in a very real and visceral kind of way.
Kind of. Okay, so you held up a few, and I wonder if how these things are cut has an effect on the crystal.
So, with something like this has had no shaping done by human hands. This is completely natural. It came out of the earth in this form. It's been cleaned up. In most cases, quartz will be covered with things like laterite soils or iron compounds, and a good scrub or an ultrasonic cleaner, or sometimes an acid bath is necessary to take that off and expose the inside. And the primary drivers of any rock, mineral, crystal, or gem's energy are things that occur at the micro level. Things like its formation process, which kind of, we'll say, broadly gestures to the level of action of its energy. The crystal system could be more like the primary mechanisms involved in the healing process. And then composition, what are the specific contributing factors to the energy you perceive? So no amount of cutting, polishing, grinding, rubbing, shaping, crushing changes those internal factors for the most part. But we could say that form and function are interrelated. There is a natural tendency for something in its form like this to want to, kind of allow energy to travel through the termination and in a single direction. If you have a quartz cluster, it's going to kind of broadly kind of distribute energy in the directions where everything is pointed. If you have a rough hunk, which I don't have an example of nearby, well, this guy here, so it's made out of tiny little crystals that are all aggregated together. There's no real organization in a single focus. So by polishing, we might affect the way the energy is distributed, but we're not changing the fundamental energy. It's rather like, if we continue with our music analogy, it would be like listening to the same piece of music through different kinds of speakers or headphones. You hear the same thing, but maybe certain qualities are emphasized with one shape versus another. So if we've got a perfectly polished sphere, energy is going to radiate very evenly in all directions at once. If we have something that's, polished into kind of blobby shape, then we might not get as equal a distribution of energy, even though if mass, quality, and all the other parameters are the same, it's the same fundamental energy.
It looks like it's growing the way a plant would grow in the same type of sense, where we were just holding up that smoky quartz. It's like if it wasn't removed from its source, it would continue to grow in that directionality.
I mean, in theory, if all the conditions present during its formative processes were still ongoing, so something like this forms by hydrothermal activity. So when molten rock magma is reaching up from the mantle and into the crust, and it finds little pockets and other places that it can kind of pool around. It interacts with its environment. It is super pressurized in the mantle, and as it kind of comes up towards the earth, there'll be the chance for things to sublimate from it. So what will happen with this hydrothermal process is water, which is bound by the host rock, it has no place to go, can be superheated and super pressurized far above the normal boiling point. So it's going to dissolve all sorts of things along the way that water can't normally dissolve at normal temperatures and pressures. And then when it finally gets a chance to either cool down slowly or expand rapidly, it'll start depositing things. So as long as that original silica-rich solution were still present and all the conditions were unchanging as far as temperature and pressure go, this would have continued to grow. By the time a human found it, that had long since stopped. This is a piece that was actually mined in the 1940s as part of US government activity in the state of Minas Gerais, Brazil, to get optical quality quartz for communications technology, because crystal radios at the time were, you know, the the best thing you could do to communicate long distances. And the higher the quality quartz, the greater the optical quality, the clearer the signal, and the farther it could be detected. So it'd be like having the best smartphone today. So a lot of this stuff's just stayed in warehouses for decades because they didn't want it to fall into enemy hands during World War II. And that's yielded some fun and interesting stories in the mineral market ever since.
Yeah, wow. Okay, so some people like myself are probably thinking like crystals, I I feel really drawn to them. How do I figure out what to get?
It's a great question because there's so many options. I mean, if you're shopping online, it's pretty much endless. If you go to your average crystal store, you're probably still going to be overwhelmed. So my first piece of advice that I give people is to start with what you're drawn to. That's usually a good indicator. If there are, labels in the store and you're overwhelmed by all the descriptions, just ignore everything except the name and the price. And even those are not really that important to get you started. You might be drawn to something for its color or shape or texture. You might have this kind of kinesthetic attraction to it. It just feels good in your hand. You might also have an inner knowing if you're kind of wired that way. And if you've got no real intuitive connection just yet, just go with your gut anyway and see what happens. I find that most people, when they're not trying to work prescriptively, not trying to match up a particular crystal with a particular effect they're trying to find, and they just let themselves be attracted to something, they usually stumble upon exactly what they were looking for. And it's usually a better fit than what they find by trying to work prescriptively.